someone found a way past the edge of the system. What happened next was not a second attack, because there was nothing left to attack. Every internal service accepted the request without question, since anything arriving on the internal network had, by definition, already been checked. One boundary, checked once, and behind it, a flat space where every service trusted every caller. So let's design an API gateway properly and be precise about the one thing it can do, the several things it cannot, and the mistake that turns a single breach into total access. A gateway earns its place by holding the concerns every service would otherwise re-implement. It terminates TLS, so certificates live in one place rather than 40. It routes, so clients see one address instead of your internal topology. It rate limits, so abuse is stopped before it reaches anything expensive. And it authenticates, which is the interesting one. Without a gateway, every service passes tokens itself, and you end up with several implementations of the same security-critical logic that drift apart over time. One of them will accept an expired token, and nobody will notice for a year. Centralizing that check is a genuine improvement, and it is exactly where the mistake begins, because centralizing the check is very easy to confuse with the check being finished. Take the token check itself. The obvious implementation calls the identity provider on every request to ask whether the token is good, and that puts a network round trip and a hard dependency in front of every single call you serve. When the identity provider is slow, everything is slow. When it is down, you are down. So the gateway validates locally instead. It fetches the issuer's public keys, caches them, and verifies the signature itself, then checks the claims that people skip. That the issuer is who you expect, that the audience is actually your API, and that it has not expired. A signature that verifies only tells you the token is genuine. It does not tell you it was meant for you. The cost of validating locally is the revocation gap. A token you did not ask about might have been revoked a minute ago, and you will honor it until it expires. You close that gap with short lifetimes and refresh, not by reintroducing a lookup on every request. Here is the error that caused the opening story. Authentication and authorization are different questions, and the gateway can only answer the first one. It can establish who is calling. It cannot sensibly decide whether this particular person may modify this particular invoice, because that depends on data only the invoicing service has. So the identity has to travel inwards, and the way it travels matters enormously. If the gateway strips the token and forwards a plain header saying which user this is, then any service that can reach another service can claim to be anyone simply by setting that header. You have replaced a cryptographic assertion with a suggestion. Forward something the receiver can verify. The original token, or a short-lived internal token, the gateway signs. Then every service checks it again and answers its own authorization question with its own data. Checking twice is not redundancy here. The gateway and the service are answering different questions. The design principle underneath all of this is to assume the wall has a hole in it and ask what an attacker reaches once they are through. If the answer is everything, the architecture has one boundary and a soft interior. If every service independently verifies who is calling and decides for itself what that caller may do, then getting past the edge buys an attacker exactly one service. And keep the gateway thin. It is enormously tempting to put a small piece of business logic there because it sits in front of everything and it is convenient. Do that a few times, and the gateway becomes a component that every team must change, that nobody can test in isolation, and that cannot be taken down. Policy at the edge, logic behind it. Verifying at every hop instead of at one perimeter is the core of zero trust, and it is a much larger subject than a gateway. The cybersecurity architecture series works through it from the threat models upward, including what it actually takes to run this. In an estate you did not design from scratch, that is where to go next.